this weekend make the cider. And
All right.
200 bottles of cider. And I'm like, oh, we got labels. And then it was like, put this thing in the list.
Sorry.
If
you're just joining us, we're waiting for Evan to finish his cider story.
We have 2 minutes left.
Oh, we have 2 minutes left? Oh.
Is that clock slow?
Slow.
Oh, well.
I was wondering that.
Did you finish your cider story?
No.
You want to come up here and tell it?
Yeah, stand in front of the class.
All right, so we're talking about alternators. And, oh man, we got to finish everything today. All right, so alternators produce three-phase AC in the... How'd you guys know it was the stator?
I don't know. Right there on our notes. The last thing I wrote.
Which part is this?
The stator. Does that stay or no?
It stays.
Yeah.
It's a stator. What part is this?
The rotor.
Rotor. So the rotor rotates inside of the stator. Each one of these is a
North or south pole.
so that'd be like north, south, north, south, north, south, north, south. Down here we have the
Slip rings.
slip rings, and there's a in between them an insulator, sometimes called a mica. All right, and then inside of there are two types of windings. I don't know. It sounds more like a trivial question to me than anything, because when you put an alternator on an aircraft, you don't get to choose which one you want. You just, hey, that's the right one. That's the one you get. Well, is it a delta or is it a Y? I don't know. It's the right one. So, but there are two different types that they want you to know about. You have the delta, which just looks like a D, the delta, and the Y, which doesn't look anything like a Y. Oh, I'm sorry. I started without you guys. Then you walked in front of the camera. So everybody knows who's late. Did you bring me anything for being late?
They brought you their presents. And that is the single most important piece of the
I know. So anyway, if you just missed that, you are doomed. All right, so write that down. We have the delta, we have the Y. Let's say a delta Y. Just cut out some of the stuff that's not important. All right, so what is important? So we are producing inside of the stator three-phase AC, but what do we need to have on the output?
DC.
We need DC. So how are we going to get DC?
Full wave rectifier.
A full wave rectifier, rectification of a three-phase current. And we really haven't talked a lot about diodes, but you've worked with diodes, so you know how they work. And I think we've even, yes, we have talked about bridge rectifiers many times in this class. Have we not? So,
At least once.
at least that's all that matters. So, and it does go across too. So we got nobody get hurt. So there we go. So we know how a bridge rectifier works, and I can kind of move on. So what happens is within each winding, we are going to get, that's what it looks like within each winding. But across the bridge rectifier, it's only going to take the best of each one, and that's what we are left with. So an effective ripple current. So in a generator, what converts the AC into DC? Commutator. So in an alternator, what converts the AC into DC? The rectifier. So the nice thing about having a rectifier circuit is we do not need a reverse current cutout. What are you doing over there?
What's that?
You moved.
Oh, we
We don't need a reverse current cutout. Why do we not need a reverse current cutout?
Diodes act as such.
Because anytime we start to get the load that's going to back up through, it is going to say, no, you don't. So yeah, if it starts to back up this way, nope, not going to work. So the diodes block out any reverse current. So we don't need a reverse current cutout. That's something I would write down. So, there we go. Three-phase stator and AC. Let's see, we have maybe delta or Y. Okay. Oh, I got to find the pen.
And that's a type of alternator? Delta or Y?
That's the windings, type of windings. So the type of alternator would just be the brand name. Chrysler, Ford, AC. So stator, maybe delta or Y. Let's see. Dun-dun-dun-dun.
There is a reason that they do that. It said in the book.
Yeah.
For high delta is good for high current and low RPM, and Y is good for high voltage.
Armature has 3 separate windings. I got that. Windings. Let's see. We'll go this way. To create DC output, the alternator
So actually,
uses a 3-phase full wave rectifier. Uses a 3-phase full wave rectifier that consists of 6 diodes. Consists of 6 diodes. This also means G diodes. That's exactly it. Yes. So it uses G diodes. 6 diodes. Diodes also act as a reverse current cutout. So we already talked about the 3 main parts: stator, rotor, diode assembly. Operation theory, same as a generator, but armature is stationary and the field is rotating. All right, so what are some of the advantages? Commutator, drive methods. Yeah, we talked about drive methods. Let's see. Okay. What are some of the advantages? I don't have them in my notes, but advantages. Why do I want a this thing alternator over a generator? It's smaller, lighter. Puts out a lot more current. Why does it put out more current?
Because it doesn't need to rely on the brushes to be able to.
There we go. I think we talked about that yesterday. In a generator, all of the current has to go. Yeah, we did talk about that. All the current has to go through the brushes on a generator. What goes through the brushes on this thing?
About 5 amps.
Yeah, about 5 amps. And what's it going to?
The slip rings.
That feed the
The rotor.
rotor or field. There we go. All right. Let's see. And unlike automotive, oops, this is kind of, there we go. Unlike automotive, alternators, as far as I know, aviation alternators are all externally regulated. All right, so you go to the store, you buy an alternator for your car, truck, or van. It's almost always going to have, it just comes with a regulator built right into it. So you don't have to, that's a nice thing. You don't have to worry, well, I have a bad alternator, bad voltage regulator. You just go down to AutoZone, you just pick up a new one, you bolt it on, and well, whatever the problem was. But in aviation, unfortunately, everything is split out. So it makes it harder to troubleshoot sometimes, or easier to troubleshoot. I guess the I don't know, good side or downside, what does an alternator cost for a car?
$200 for
$200. Yeah, I put a new voltage regulator in my airplane. I think it was $450
You know.
for just the voltage regulator. So yeah,
What's the purpose of separating them on the aircraft?
I don't know. I could think of a reason and give you something. I would just be making it up.
his $450 will give you the reason.
Yeah, they can charge more for each component.
So when on yours, where is it located? Is it
On the firewall?
On the firewall itself.
The
So
regulator.
It's kind of away from the heat sources, suppose, perhaps.
About yay far from the
Okay.
alternator.
Okay.
So sure. Attached to a firewall, but probably oil cans. So, well, the alternator's just kind of sitting there. All right, so they are Let's see. Let's see. Yeah, I don't have time for all this. I will just tell you that just like anything, it's progressed. So it started out, back when and the reason why alternators weren't like invented first is because they couldn't find a way to really regulate stuff without old-timey voltage vibrating things, right? And so then once diodes were invented and able to handle the heat, because this produces a lot of heat, so these diodes do get a little toasty, and so they're always attached to the aluminum case in a way that will take the heat away from them, draw the heat away. And so, yeah, they're still, I think, a little temperamental in there. So once they invented diodes that were usable, then they were able to create alternators, and we switched over to alternators. And so anybody who still has a generator is usually doing an STC to get rid of the generator and put an alternator on, because an alternator will definitely put out a lot more amps, lighter weight, and they have a lower coming in speed, though it seems to be the way they operate. Then, of course, the original alternators had not a 3-element voltage regulator. They would have a 2-element voltage regulator. I know one of the books actually says something about, oh, you don't even need a voltage amp limiter. Just most airplanes have a circuit breaker. I'm like, that's true, but no, you don't rely on a circuit breaker every time you draw, you put too much of a load on accidentally. What, pops a breaker? I mean, that'd be terrible. So I don't know about that one. So anyway, you'd have a 2-element, and then we've gotten away from. Nobody would, I don't think, would want to put a vibrating type voltage regulator back on their plane. In fact, that's why I bought a new one for my airplane. I was having some little issues with it, and I just had an old Cessna one on there, got rid of it, and got a newer solid state one. So let me see, just finish up with this, and we'll look at that. Yeah, I wanted to spend at least a little bit of time. Let's see what I got here. Talking about power distribution systems. I don't know if you can see that very well, but this is off of our trainer, the electrical systems trainer. Can you guys see it at least reasonably well, or not at all? So don't even waste my time.
It's a little blurry.
Can I turn the light off?
Yeah. Try the other one.
There we go.
Yeah, a little better.
All right. So let's kind of run through it. At least it'll quickly give you an idea. This is pretty close to what you'd expect. So where's my master switch?
Wasn't there something we were talking about when we were working on this?
Master
Like
switch, bottom
something-
middle.
Yeah, something was in the wrong spot.
A few things. All right. So we start down here with any aircraft. There's a battery. The battery just goes to ground. So we have positive. And then the battery is going to run a wire. Look at my plane. It's going to run a wire all the way up through the back of the aircraft to right behind the instrument panel. It's just a small little switch, which is the master switch. And you kind of see how they wired this in there. So that's all in series with this master switch right there going to ground. So when I close the master switch, then I have current flowing through this coil right here, which is just a small piece of wire. And this master solenoid is going to be right back there next to the battery. And this is a very short run of wire. My airplane's only about yay long. Gets to the master solenoid. Master solenoid closes. What happens?
Allows the rest of the current to go through the system.
The big wire. It's a big wire right here. Goes all the way up to the I don't think I have a DC bus. Mine just goes right up to the master bus, which is right by my knee. So you have the master bus. So everybody see how you got power. Close the back master switch. You energize the master solenoid. It goes up and pretty much just energizes the master bus. And off the master bus, you're going to have all of your loads, right? We've talked about that many times. A lot of airplanes do have an APU relay, like this one has. And what that is, so where's the receptacle? When you plug in, APU is auxiliary power unit. When you plug in ground power, it automatically energizes this APU relay from the ground power. You don't go in and turn on the master switch. As soon as you plug it in and turn on the ground power, bam, it lights up the aircraft. So you get power from the APU, which don't know if that's, I guess this is the positive and negative off the APU. Yeah, that's what it is. So positive, negative off the APU. It's a plug, which will energize it off of the APU, closing this right here, which takes battery voltage and goes right through the master solenoid, down through here. And once the master solenoid's engaged, back up to the DC bus and master bus. Follow? So the takeaway from that is, if you energize it from outside the aircraft, you're going to have power to the aircraft, just like that. You don't have to go in and turn on the aircraft. It's already on. You'll see diodes. Diodes, generally speaking, are hanging out around relays so that when the relay opens and it creates that voltage because of the way the relay acts, right? The collapsing field in the relay, that's counter EMF, which creates a voltage, and that voltage will spike, and that voltage tends to want to arc across a switch, which ruins the switch. So they'll put a diode usually around all of these solenoids, taking that to ground. So the voltage spike goes to ground. All right, so we got that. We got the master bus. Another interesting thing about aircraft, so we got the master switch. Where's my starter switch? Starter.
Starter switch would be above.
It's like top left. Oh, it's right there in the middle.
Middle. Starter switch. All right. Most aircraft, to the best of my knowledge, and I'm pretty sure I'm right about this, do not have a circuit breaker in the starter circuit at all. They just don't, because they want you to be able to start that aircraft. If they do, it's certainly not anything going to the starter, but you can see right over here, the starter is just a basic. Off the master bus, we hit the master switch, bus is live. I want to hit the starter switch. This is a momentary switch. My aircraft, it's you twist the key. A lot of them, some you push a button. The old Cessnas, you actually grab a T handle and pull it, and it engages the starter and hits a button at the same time back in the starter. That is going to go through a solenoid. Why do we have a starter solenoid?
To be able to take the amperage.
Starter draws a lot.
Yeah, because you wouldn't want to run a triple-aught wire through this right here. So starter solenoid is very close to the starter, engages the starter starts, but this is kind of interesting over here. When we power up this, power comes through here and goes to two places. One, it goes to the starter. Two, it comes up to an avionics cutout relay. So as long as this starter switch is engaged, this is engaged, which opens that, shutting off your avionics.
So, is that like in the real world as well, where?
God, I hope not. If I had this in my airplane, I would get rid of it.
Yeah, I was going to say, that doesn't seem right. It's like you have your avionics on generally before you start your airplane.
Nope. No, you don't. You start your airplane, and then in my airplane, I had it wired so that I have an avionics. Well, Cessna came that way, but I just did a little different. You start up the aircraft, get it going, then you flip on the avionics bus right here. And I don't have that. My airplane actually came with a cutout, but for the rotating beacon. So during the starting, the rotating beacon was off. Yes.
Maybe I can imagine that's there so that way all the power goes to the starter. So if you have all your avionics on and it's draining your battery, you crank your starter, turns off your avionics, all power goes to starter, you let it off.
Well, that's exactly why I had a beacon cutout switch, because the beacon in my airplane is not LED and it draws a lot of power. Mm-hmm. So yeah, that's what mine was for. Perhaps they're thinking about some of the old-timey avionics with the giant tubes and stuff, and they do draw a lot of current, is where the new stuff just doesn't.
Well, could it also be like an intermittent power draw with the starter, and it could like cycle the avionics on and off quickly and damage things possibly?
Possibly, yeah.
Yeah, I always thought it was just to protect those more sensitive items on the avionics.
Well, that's why I have a master switch, and that's why you don't turn on the avionics until the aircraft is on, and
redundant if you have the avionics switch.
Well,
and the generator switch engaged. What?
Or like a failsafe. It's like if you did start it with the avionics master on, and it would damage it, it would be like, no, you can't do that.
Sure, but in my opinion, and thinking about how my avionics are wired, if I hit the starter, then I'm going to have a drawdown of voltage, but that I don't think is a big deal. I don't like the fact that they're cycling on and off like that so fast, because that resets everything, and so it's like, why'd you just do that? So I don't know, not my choice, but it's the way this is. So you often have, and the point is, you often have cutout relays installed in the aircraft that may cut something out when you hit the starter. And yes, there is a concern about spikes on your avionics, which is why we don't turn on the avionics master until we've started the aircraft. Aircraft is running, and then we flip on the alternator switch. Or Cessna's, it's 2 switches in one. It's a split rocker. And so if you just use your thumb and hit it, you hit both at the same time. I just turn on my alternator the same time I turn on my master. If I'm going to start the engine, I don't worry about it. I don't do half of it, turn on the master, get it running, then turn the generator on. I just turn the alternator on at the same time. So alternator comes on, everything stabilizes. I look over, make sure I've got oil pressure. I got oil pressure, I got voltage. There goes the avionics master on. But anyway, we're talking about power distribution. All right, and talk about the generator circuit. So once the master's on, master bus is energized. We have a 35 amp circuit breaker and a 5 amp circuit breaker. Notice that they put that in series with that. That's the way they want it. And then off of that's the ammeter shunt. So this 5 amp right here is simply going to go over here to the over voltage relay, out through a filter, which is a noise filter, up to what they're calling ignition, which is voltage regulator positive in. Is an alternator self-exciting? What does that mean?
It needs an outside source of current to be able to excite the wires.
Right, I don't think I wrote that down, but this rotor has absolutely no residual magnetism at all. None. So no residual magnetism, which means that
It's an electromagnet.
it's only an electromagnet. Therefore, we got to have electro going to it, or we get no magnet. So where do we get electro? Right through there, through the 5 amp, through the over voltage relay, back around through here to the filter, to the ignition, which would be input.
And is that the same for all alternators? All alternators are not self-exciting? Or is there some examples of alternators that are?
I think they're all not self. I gotta be careful, because now they're starting to make. There are some that I believe are. There's backup ones that are very tiny, and I think they run off permanent magnets.
Okay.
So
I just didn't want to say like all alternators.
yeah, yeah.
But that's only to start it up. Afterwards, the alternator is able to pick itself up, and then.
Oh yeah, once it's started, it produces enough voltage that it feeds itself.
But generally, they're not self.
Generally, they're not. You gotta have that field. All right, so we got the volt. So here we go. Alternator B goes to battery. That's our output, not input. They call it battery. It's going to the battery. Notice here it goes through an ammeter shunt, which has an ammeter. So that is going to tell us what? What is it reading?
The load on the amp, or the alternator itself.
Alternator load. Where is it normally in a small airplane?
Between the master bus and the ground.
Between the master bus, it would normally be right here. Somewhere in this line, going to the battery. So right here. Normally, the ammeter is right here off the master bus, telling me what?
Total load.
What's going in the battery or out of the battery. That is typically the way small aircraft are wired. Large aircraft will do something more like this. This will tell me what the generator alternator is actually putting out. It's up to you to figure out where it's going. You have no idea if it's going all to the battery, if the battery's feeding something. You would not know in this system. You just know what the generator's doing. Of course, ground goes to ground, and the field plus, field minus, because
Field in, field out.
we got 2 brushes. One brush is positive, one brush is minus. All right, so we have the external regulator, filter, and the field. External regulator. So kind of looks like this is the positive, because it's got a positive on it, and we have positive coming in here. And what does the field need?
Ground.
Ground. There is often another wire coming. Well, the F plus, I'm going to say, generally speaking, it's not F plus, it's stator, STA. And that is feeding back into the voltage regulator as a sensing loop to help the voltage regulator run. And then this case, the field is going to provide what?
Positive.
This one right here going to F minus into the regulator. So it's going to provide a what for it?
Ground.
Say it.
Signal. But we
Positive or negative?
Negative.
Negative. And how do I know that?
It says F negative.
Because that's F negative. It's not real hard. All right. So not only do you have the voltage regulator, which, like I said, it's solid state, and we're not ready to discuss that. But there's also an over voltage relay. So in the event that the voltage goes higher than what it should, because it's the job of the voltage regulator to keep it there, the over voltage relay will trip, protecting your avionics.
Can you say that again?
In the event that the voltage regulator allows the voltage to go too high, it will trip the over voltage relay. So the over voltage relay is going to open, and you're going to lose all alternator.
So if you have over voltage, that's your protection.
Right. Boom. There it goes. It's
so then
gone.
that's sort of self resets when you.
It does. I can't think of many things in an airplane that self reset.
Oh, so.
I can't think of anything.
Well, so what I mean is that over voltage relay. If you fix the problem of why it was causing over voltage, you also have to change the over voltage relay.
Nope.
Or,
all you have to do right here, alternator switch, cycle it. Alternator off, alternator on. This will lose voltage, reset itself.
well, that's what I was.
And if the problem, yeah. So and then the problem goes away, then you're good.
Okay.
Now, my aircraft, which Cessna does it a couple different ways. In my particular aircraft, the last two Cessnas I've owned, so maybe it's all of them, I don't know. When you get in the aircraft and you turn on the master switch, there's an over voltage red light that comes on instantly. So I get in the airplane, I hit the master switch, and I'm only running off battery voltage, and light comes on, says over voltage. So that's just the way they do it. It's the dual light. It says over voltage, but they're kind of depending on you, I guess, to know that it's not really over voltage because it's the battery, and the battery can't put out too much voltage. So
Is it just like an indication that it works so that you can say, oh, it actually works?
I think it's a double indication. One, the bulb is on, and two, kind of let you know your alternator's off, which is kind of a funny thing. So then as soon as you start up the aircraft, the light goes off. But now you're flying the aircraft. If light comes back on, that means you've got over voltage. So what do you do to fix it? Cycle it, and then if the light comes back on, well, it's overvolting, and so what are you going to do?
Land, hopefully.
Land and adjust the
Voltage regulator.
voltage regulator. Even solid state ones usually have a little small screw set in there where you can adjust it up or down a little bit. So maybe your voltage regulator is just a little bit too high. Back it down a little bit.
Stick your head out the potentiometer in there.
You do. You can reach around. It's fine. That's why you fly with the cowling off. You think you're going to have a problem. All
Maybe
right.
a variable resistor in that voltage regulator.
Well, it's all solid state, so possibly, yeah.
No, I'm just trying to think of what that screw would do.
Yeah, we can surmise that it would be like a variable resistor. I have several slides in here that I was going to go over, and at one point, this is what a transistorized voltage regulator looks like, and we can go through all that thing. And I think I got another one. This is the one that came out of the EST across the street. Yeah, but it is just beyond what you need to know, and I think it would frustrate you to have to try and figure this out when what I really need you to know is how this works.
Spins.
And
You look like you're holding a little cross. It's like it's like you.
The holy
you're
hand
like
grenade.
I pray to the
I want to take
baby.
a picture of you doing that. That was.
Pray to the baby Jesus. You guys get this stuff, man.
Wait. Oh my God, you're gonna laugh.
Howard
so
B.
hard.
was
It's so funny.
All right, Mom, I'm taking the photo.
So there's a saying: let's keep the main thing the main thing. Yeah. What'd you say? I was thinking, I don't know about that one.
You're making me
All right, so the alternator has 4 connections. We talked about those. They are the
Field windings, the battery positive out and ground.
you got the B. B stands for battery. Is that alternator input or output? Output. In our electrical systems trainer, we have an F plus, which is located very near the battery. Let's see, that's our power. I don't need to read all this. So F minus is our field. Oh yeah, our electrical systems trainer. That's what I'm looking at. I forgot. This is exactly how it is. It's battery, ground, F, and F. When you get down to doing your project in the lab and the alternator you use, you're going to have battery, ground, stator, and field. And those would be you won't have it. So you have to.
So stator in this case would be the F positive if we're looking at this one, for example, F plus would be our stator.
I'm hesitant to say yes. I believe so, but I don't want to say something that's wrong just to try and look like I know everything. When you're working with alternators, this looks very simple. You should see the wiring in my airplane. There are not 4 wires going to my voltage regulator. There is a wire loom going into my voltage regulator. There's a lot going on. You need to be very careful. You need to take photographs. You need to write things out because things go from real bad to really, really bad real quick when you start getting these wires mixed up and you start burning up alternators and voltage regulators. I just told you what I paid for my voltage regulator, and the alternator I haven't priced out yet, but I'm sure it's near $1,000 or so. So you could easily burn up $1,500 that fast. And to have to walk in and tell the boss that you just need another $1,500 off a job you've already been on for too long is not going to go well. So it's one thing if you're slow. I always said I don't mind people that work slow in the shop as long as they're careful. Speed comes with experience. But if you're trying to be fast and you just break stuff, then that's really bad. So, all right, so that's the distribution system in a very short version there. All right, lights back on. Let's see. All right, I got the overvoltage. We got the alternator control, which, yeah, boy, I got like pages and pages of alternator controls to explain those things.
So you say you have a loom going into your voltage regulator.
Oh,
That
yeah.
means there's different things also controlling it.
The overvoltage is all in one. I don't have a separate one. It's inclusive and all kinds of stuff. All right, let's talk about a little bit of troubleshooting stuff before we get into motors. Troubleshooting. How much is battery voltage?
12.6.
Well, give me a good number.
12.14. 14.
Troubleshooting. All right, so you go up to the alternator and you've got 13.8 volts. What's your problem?
It's good.
It's not producing enough voltage.
13.8 volts, that's good, right?
What's that?
13, you got 13,
Yeah,
you
isn't-
gotta adjust the voltage regulator.
Battery's only good for about 13.2. So if you're picking up, I should have said that. If you're picking up about 13.2 or 12 volts at the alternator, what are you reading?
Just battery.
Battery voltage. So a lot of people make that mistake. They'll take a voltmeter, they'll go up to the output of the alternator, put it right on the big B terminal, go, man, I got like 12 volts. It's not the alternator. What is it? It's the dang alternator, because you just measure the battery voltage. What should the alternator be putting out?
13.8 to 14.2.
Yeah, 13.8, 14.2. You got to have more than the battery, otherwise you're just reading battery. So make sure that you remember that. So output needs to be above battery. So output needs to be more than battery. Well, hey, it didn't say battery. One of the things you can do, again, I use jumper wires and get them out away from the propeller, but you can check and look at your voltage on the alternator, start the engine, and see what the voltmeter does. What should it do? Should go up, which is exactly what I'll ask you in class when you hook it up to the little machines up there. Say, all right, well, I turned it on and we have, 11 volts. How are you going to know if the alternator is working? Well, when you start the motor, it should go up, right? And if it goes up, it's working. Well, what if you have 11 volts on the machine, and when we start it up, it only goes to like 12 and a half?
Not good.
Hey, it says voltage regulator. So what did I have to begin with? At 11 volts.
11 volts.
What am I measuring?
Your battery.
Battery, and then I started it up and went to 12.5. Alternator's working, right? Because it went higher. As soon as I started turning it, it went higher. So that means it's working. But is it working the way I want it? No, its voltage is too low. So what's the problem usually? Voltage regulator. Bump the voltage regulator up. All right, so not hard. Let me see. And let me see.
Always test the stuff that's sitting right in your face.
Yep, test that stuff first. I mentioned before, if you're working on a twin aircraft, people swap parts all the time. It can, I would say for troubleshooting, one of the biggest tools is actually use the manual. Manuals have a troubleshooting section in it that tell you exactly what to do. If you're working like my plane where I put in an aftermarket voltage regulator, it came with a fantastic troubleshooting chart. And a lot of the new voltage regulators have LED lights on them that'll flash at you and tell you what's wrong. Just read the LED. So yeah, if something's not working, you pull out the little sheet. If the red LED is flashing, then you have an open to the, like, oh, okay. So
Super fancy.
yeah, super fancy. Not that there's real important differences between automotive and aviation alternators. I got this out of a textbook that referenced FAA alert number 63. So that is my source, FAA alert number 63, as written in a textbook. So, which is to say, you can be the judge of this. Although alternators are bidirectional, and that's true. What does bidirectional mean? They go either which way. Aircraft engines turn the opposite direction of most cars. Do most car motors turn to the right? I don't know. Yeah, you'd be looking at the crank coming out at the back of the engine. So that'll be to the
Transmission side?
yeah.
Yeah, counterclockwise.
That's what I call it. Well, that's
Look
left.
at the other end, it's counterclockwise.
So who knows?
The belt drive. So.
According to this, aircraft engines turn the opposite of most cars. So,
Clockwise is distribution.
all right. And they say, therefore, cooling fans must be reversed. To that, I would say, well, that's not necessarily true because sometimes we have alternators that are driven off gears that go one way or a belt that goes the other. It's like they're all over the place. So, whatever. Pulleys, what?
No, just, I guess if it doesn't matter, whatever, but I was curious about what you said, I just didn't really get it.
Oh, according to this, aircraft engines turn the opposite of cars, therefore the cooling fans are going to be backwards.
Oh.
Yeah, that doesn't.
Also,
No, I mean, I get it, but it's also like, what?
Also, pulleys and belts are different. I do happen to know, a little bit of, when you go into the auto parts store and you say, this came off of my, 1974 Pinto, they'll, that doesn't fit something else. You guys don't even know what Pinto is.
Yeah, it's infamous. Come on.
It's an awesome car, right? And so, who cares which way the engine's going, because it depends on how many belts and pulleys it ran through to get to where it's going, because some go this way and some go. So anyway, same with aircraft. You never know where you're going to end up. All right, so radio suppression is different. Possibly true. I would imagine that our alternators for aircraft have better filter systems for radio noise suppression in them, a couple of more capacitors in them. Belts and pulleys are different. Yeah, they're different in cars too, I've noticed. Brushes have different compound to prevent corrosion. Does it? Higher graphite contact and tin plating on leads. Again, not my words. The stator is definitely delta wound in aviation ones, according to this. I did. These have a shorter drive shaft and different size threads. I don't know about that. Anyway, that's what they said. So
Why are they comparing it so much to a car?
well, their point was because it was an FAA letter, don't go down to AutoZone and get an alternator because it's so very different. So, I would have just said, yeah, the mounting holes are different, so don't do that.
But that was my question from yesterday. Then.
I'll just keep drilling.
And that's why you just
If you could find one that
fits.
fits, yeah, you could probably use it.
Yeah, just grab your little AutoZone and put a couple capacitors at the end of it.
That's right.
All right.
Oops.
Yeah, if you can
There
find
you
one
go.
that fits the same exact mounting holes and everything. Congratulations.
I don't know.
They
Honestly.
said they're from. They said they're. What did you say that the alternators are out of an aircraft? They're what did you say they were manufactured? They're Ford. Man.
What?
The Delco Remy which one we're dealing with.
Wow.
That's not against you. That's against everybody who keeps asking you everything. That's what they're doing anyway. You should have seen it. The poor guy left to the electrical systems trainer. I mean, it was like chaos in the classroom.
God,
Everybody's, where's Evan? Where's Evan?
Take that off, please.
Don't ask Evan.
Don't.
Ask. Oh, yeah.
You can ask me,
I
but
could
you're
just-
not gonna get the right answer.
Don't ask. I don't freaking know. Okay, I got to move into. Let's see. Yeah, I do have some notes on AC generators. A lot of the manuals and textbooks that we have do say right up front, hey, we're going to use the word AC generator and AC generator and AC alternator. That's the same thing, and we're just going to use it as one thing. But there are also AC generators. So what do you guys have on your planes?
There's starter generator.
Starter generators. But yeah, which you'll cover later. But the output, yeah, so it's got to be a generator because it's a motor at the same time. So larger airplanes have, which you'll get into with Phil, starter motors. Old cars have those too, I think. Yeah, they're very large starters. So it acts as a starter, which is a motor that we're going to look at, a DC motor. And then once it's done being a motor, now it's just a generator because they're so exactly the same. So let's see, AC generators, AC alternators, synonymously used in the industry. Large aircraft use AC power employing AC generator because an AC generator is similar in operation to a DC alternator, but without the diodes. So what do we get then if we remove the diodes?
An AC alternator.
AC alternator, so the output is AC. All right.
Rating current alternator.
Oh my gosh, I forgot about this. This is I'm like, why would I even put this in here? This is terrible. This is asked. So talking about AC generator. AC generator. Yes, I got that. So it's going to output is AC. Output is AC. So it's like an alternator without diodes. Yes, I can put that.
The diodes that are the rectifier.
Yes, without diode. Without diode rectifier. There we go. However, must be turned at an exact RPM to maintain proper frequency. Frequency is dependent upon speed of rotation, speed of rotation and can you guess? Speed of rotation. Why did you do that again? Just got rid of that. Speed of rotation. And
Number of
number of poles. Number of field poles. The formula, we're going to head over here, get out the pens. Formula is, this is out of the book, F equals P over 2 times N over 60, or Pn over 120, which is what this, I could not figure out what they were trying to do with that, but I did figure out Pn over 120, where P equals number of poles, F is the frequency, which is cycles per second, or hertz, and N is the RPM. You wouldn't want to make that the R, but
Yeah.
whatever.
Or the RPM.
Yeah, so example, we have a two-pole generator, AC generator, running 3,600 RPM. Therefore, what is the frequency? So frequency equals
P times 36.
P times N over 120.
60.
So that's 2 times 3,600 divided by 120, which equals
Yeah, about 60.
7200 divided by 120, which equals 60. And I bring this up because you actually have a Q&A question the FAA expects you to know how to use. Like I said, I'm just going to be honest with you here. In the book, it actually has F equals, let me see. F equals P over 2 times N, 60. N 60. And out of this, they get equals Pn over 120. And I guess you're just multiplying.
Same exact thing.
2 times 60.
Oh, it's cross multiplying over here. Okay. Yeah. All right, but the question asked in the Q&A is find the speed. What is the speed that needs to be to achieve 400 hertz. I don't remember if this is the exact Q&A or not. Probably is, of an 8-pole generator. Is that exactly it?
That is.
Okay, so using the formula that we just had and doing algebra and moving stuff around, it becomes F times 120 divided by P equals N, which is the speed. So the frequency, 400, times the constant of 120 divided by the number of poles equals the RPM you have to go. I didn't do all the math here, but I do know that it equals 6,000.
A little bit of speed, but what's average speed of a generator, like alternator currently?
I don't even know. I'd like to know. I don't. It's not hard to figure out. You just do the math on it. It's just not something that's
Pulley ratios.
pulley ratio or gear ratio, a lot of them.
Okay. Alternators also can be driven off gear?
Oh, yeah. So the big, we'll get a little bit more into this in the next class, but Continental, they tend to run a lot more stuff off of gear drives than Lycoming does. Lycoming runs, the starter hangs out the front of the engine and rides on a removable gear ring. And their alternator's belt driven off the front on almost all engines. So it's up there in the front. You have a drive belt up there, which is not a big deal. Continental, my engine uses a belt driven alternator in the back. So when you get into the big bore Continentals, specifically the 500 series, the 520s and the 550s. Those are their biggest two. There's two versions of those engines. And you're actually just expected to know this. If I said, yeah, it's a sand cast, not a per mold, you're supposed to go, oh yeah, sand cast, and you have that vision in your head. So the sand cast versions have belt-driven alternators. That's like the biggest difference that you can see just, looking over it. It's got a belt-driven alternator, and the alternator's on the back. So they off the starter adapter drive in the back, because Continental runs the starter out the back of the engine, and they run at 90 degrees. So it's got this washing machine spring stuff in there. If you ever worked on a washing machine transmission and you worked on those, they're the same damn thing. So Sandcast runs belt-driven alternators, but the per mold runs gear-driven alternators. And they have had some serious problems with these gear-driven alternators. There's a coupling that is extremely sensitive up front. And when the coupling goes out, it tends to take out the whole engine. So, yeah, and it's one of these things where the directions for doing it are absolute and exact. And if you miss a step or don't do it exactly the right way, you will destroy the engine. And it is a $100,000 engine that you will destroy.
Of course it is.
And that's assuming you don't just kill somebody, because that's usually what's happening. The engine, we're talking about planes with 550s and 520s are not, they're planes that are going places. They're in the mountains. That's why they got the power. So they're going long distance over places that they don't want problems. If you want to, your people who have Cessna 150s with the little 4 cylinders, they're typically, running around the valley and stuff. But bigger the engine, the further you're usually going with these things. So, yeah, they're a problem. And so you got to follow that. And I guess since I'm on that little soapbox, I will say that it's just the whole project that I had you guys do with the ADs on the magnetos is a lesson that I want you to hopefully pick up. And it's not just you guys. Every class kind of goes through this growing pain, and you guys are doing fantastic. But I'm hoping that you see that there's one specific one in there, but all of them are this thing called confirmation bias, and I see every class do it. You look at the AD, you see a picture, and you go, oh, it must be that. And you assume that it's that thing, or you assume that the AD means this. Anytime you make an assumption, or a confirmation bias. You guys know what confirmation bias is? It's like, it works a lot with people too. It's like, well, everybody who wears a black cap, they're dope smokers. So that guy's dope smoker, so, so I'm going to follow him on it. Yep, I knew it. I smell him. It's like, confirmation bias is you've decided what it is, and now everything you read is only to confirm what you've just guessed, rather than saying, no, what do they mean? And I also see people doing things, and I have a really funny, it's too long of a story, but how you get to a certain word or phrase, and I see it all the time. It's like, I don't know what that phrase means. Just ignore it. I'm sure it means nothing. And then you move on, right? It's like, well, I'm sure if it was important, I would know what it meant. All right? And so you really, as an aircraft mechanic, you got to watch out for those. Those are, I think, the two biggest pitfalls I see with new mechanics is one, the confirmation bias, like, well, it's probably that in the assumptions, or two, I don't know what that means, so just don't worry about it.
If
right?
it was important, they would have made it simple to understand.
I got sucked out to sea on a small sailboat once in my life. Because my friend was reading the tide chart, and he made an assumption, and he said something about what is an ebb tide, and I said, I don't know, but I guess if it was something that I should know, it would have been common knowledge, and they would have mentioned it in school. Well, we learned what an ebb tide is. That is when the current takes you out to sea. So here I am, stuck out in the ocean in a 16-foot catamaran by myself. Well, my friend was with, so. That's how I learned about confirmation bias. And
tell us the rest of the story. How long were you out to sea? Was this like Life of Pi?
20
That's
years.
how you joined the Navy.
He taught himself to be an aircraft mechanic.
That's how you join the Navy. They just pick you up.
Yeah.